Okay, so we want to determine arc length and surface area of revolution. So it's easy to find the length of a line. Okay, so we take a line and we just draw it. We measure it. We can measure it with the tape measure. So here I have a tape measure. I can measure it with the tape measure or anything else like this and get a length. Nice and simple. Okay, so that's how you can find the length of that. All right, now suppose I have this line on the curve. So now I have 2 points. So I have this line going from this point, which is the point 1, 1, maybe to, so this is the point 1, 1 to the point 1, 2, 3, 4, 4, 3. So that's the point 4, 3. Okay, and so now I have a straight line going between these 2 points. And I ask you how to find the equation of that line. And you say that's, I'm going to use the distance formula. Okay, so I know for a fact that I can use the Pythagorean theorem. So when I go to use the Pythagorean theorem, I see that this side is length 2. And this side is length 3. And so now that means that the length here that I want, L squared is simply 2 squared plus 3 squared. So that's 4 plus 9, which is 13. So therefore L, what I really want is the square root of 13. Okay, nice and simple. Okay, so now I want to do the same thing. So I'm going to draw another picture. And this time I'm going to find another length inside my, another length here. So here's my length. And between these 2 points, whatever this point is, okay, this point being x1, y1, and this point being x2, y2, between these 2 points, the distance between these 2 x's is the change in x. So this distance between here and here is the change in x. However, it's really x2 minus x1, but that is the change in x. And the distance between here and here, this distance is the change in y. So whatever x1 and x2 are, and whatever y1 and y2 are, I know that the distance between here and here, that's the change in x, and the distance between here and here is the change in y. So therefore, the length of that little piece, again, the length of this little piece, now becomes the square root of the change in x squared plus the change in y squared. Any questions about that? That seemed pretty basic to everybody? Okay. Anybody have a question about that? All righty. Well, now what I want to do, I'm building this. So now I want a whole curve. So now I want a whole curve. And I want to look at the length between just those two little pieces of the curve. Okay, so I want to look at just a little piece. So now if I'm looking at a very small piece, let's say between here and here, as I look at that little tiny piece, I say, well, you know what's really close to that piece? That piece is almost the same length as this piece. If that's really, really small. So if it's really, 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 really tiny, want that a question? Okay. If this piece is really, 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 really tiny for really, really small delta X, much, much less than 1 means really, really small, we can approximate the length on the interval from X to X plus delta X to be the same as the line, the length of the line. So now between here and here, this is X and this is X plus delta X. I'm saying that if it's really, really small, it doesn't have too much bend to it, I can approximate the length on that curve. Now I want to take the whole curve and do that. So now I'm going to separate this curve. So now we want to do is we now want to take that curve. I don't know what that just did. That didn't do what I wanted to do. So now I want to take that curve and separate it into a bunch of little pieces. So now on this piece from here to here, then from there to there. So now I'm going to have all these little lengths. So I have the length on this piece. Then I have the length on this piece. And then I have the length on this piece. And as you can see, if we add all those lengths together, we get an approximation for the length of the curve. Okay, so the length of the curve now is approximately the sum I equal 1 to n, because I have n curves. Okay, each curve has a length delta xi squared plus delta yi squared. So each curve has that length, and we're summing them all up. Okay, so this is delta x1, this is delta x2, all the way down to delta xn. Okay, so we're going to sum them all up. So now I'm going to do a little algebraic trick. I'm going to take the length and say it's approximately equal to the sum I equal 1 to n. I have the square root of delta xi squared plus delta yi squared. And I want to multiply this thing by the square root of delta xi No, I don't. I want to factor out delta xi squared. So I'm going to factor out delta xi squared. So let me rewrite this. I'm going to factor out delta xi squared. So when I do, I end up with 1 plus delta yi squared over delta xi squared. And then I factored out the delta xi squared. So I just did that algebraically. So now my length is approximately the sum I equal 1 to n. So now I'm going to write this as the square root of 1 plus delta yi over delta xi, quantity squared, delta xi. All right, now we do the calculus. We want to let the length of all the delta i's go to 0. Which means n goes to infinity. So no L now equals the limit as n goes to infinity of the sum I equal 1 to n of the square root of 1 plus delta yi squared, delta yi over delta xi squared times delta xi. And this is calculus. That becomes an integral. So therefore, the length of a curve is equal to the integral from where you start to where you end of the square root, the 1 plus, this becomes dy dx squared dx. And this is the length of a curve. Okay. So we got a formula. Nice and simple. Okay. Any questions? You've seen the derivation. You never have to derive it again. I want you to know what the length of the curve is.
I have a question.
Yes, you can be excused. Yes.
Wait, what?
No, somebody had a question. I answered it. Go ahead.
Oh, so my question is, are those I's where it's like triangle Y and then triangle X and then I at the
Yes,
bottom?
those are lower I's because we count each one. So we're adding them all up. So this one was X1, this one was X2, this one was, so I took this string, okay, I chopped it up into little pieces and found the length of each piece and added them all together. But if I had chopped them up into smaller pieces and smaller pieces and smaller pieces, eventually end up with the integral. Okay, first example. Find the length of the curve. So here's the curve. Y is equal to 3x squared, no, 3x to the 3 halves minus 1 on the interval 0 less than or equal to x less than or equal to 4. Now, I actually don't know what that curve looks like. I should. No, I don't really know what it looks like. And I don't have a picture, but I can find the length of it because it's easy. Okay, so to find the length of the curve, I need to find the derivative. So I need to find so I know y is equal to 3x to the 3/2 power minus 1. I need to find dy dx. So dy dx says take the derivative of that, and I get 9x to the 1/2 power. No, I don't. I get 9/2 x to the 1/2 power. Now I need to find dy dx squared. So that becomes 81 over 4x. Okay, everybody with me? I haven't done anything yet. Actually, I've done most of the problem. That's pretty much what I need to do. Okay. So therefore, the length of the curve, L, the integral from 0 to 4 of the square root of 1 plus 81 over 4x dx. That is the integral. And that is very easy to integrate. Let u equal 1 plus 81 over 4 times x. So du is going to equal 81 over 4 dx. So 4 over 81 du is dx. Okay. When x is equal to 0, u is equal to 1 plus 0, so it's 1. And when x is equal to 4, u is equal to, when I put 4 in here, it gets rid of the 81, gets rid of the 4, gives me 81 plus 1, I get 82. So I get L is the integral from 1 to 82. Square root of 1 plus 81 over 4x is just u to the square root, the square root of u, which is u to the 1/2 power. And then dx becomes 4 over 81 du. So I can pull the 4 over 81 out. I'm going to integrate u, so I'm going to get u to the 3/2. I'm going to multiply by 2/3. And I'm going to evaluate this between 1 and 82. I get 8 over 243. And then I'm going to get 82 to the 3/2 power minus 1. And that's my answer.
Can you scroll back up real quick, please?
I can. Where? Where do you need me?
I got it now. Thank you.
Okay.
Dr. Locke, how did the integral change from 0 to 4 to 1 to 82?
How did, say that again, Victor?
I was asking, how did the integral change from 0 to 4 to 1 to 82?
Oh, we had to change the limits of integration right here. Remember, when you change the problem to a u problem, you can only have limits in u.
Okay.
So if once I'd substituted and did the u substitution, I have to figure out what happens when x is 0. Well, u becomes 1. And when X is 4, U becomes 82. So I have to use those limits of integration on the U problem.
Okay, so when using chain rule, when you're using chain rule, then the actual the integration of that changes, and that allows you to put those as your limits, right?
Yes.
Okay, thank you.
Okay, any questions? That one's crazy. Okay,
Oh, wait, hold on a second, please. Can you explain how you got 82 again, please?
okay, so what I did was I said here, this is what U is. U is U is equal to 1 plus 81 over 4 times X. So if X is 0, U is equal to 1 plus 81 over 4 times 0, which is equal to 1. And if X is 4, which is the upper limit, U is equal to 1 plus 81 over 4 times 4. Those 4s divide out.
Oh, okay.
I get 81 and I get 82. Good question. You guys are rocking on the questions these days.
Thank you.
Okay, you're welcome. Okay, y'all want to see another easy one, or y'all just want to skip the middleman and go to a more difficult one?
Another easy one, please.
Yeah, I was
Okay.
going to another easy one too.
Okay. All right, so if it can also be given to you in terms of y, so if your curve, just want to say this, if your curve is given as x is equal to a function of y, and c less than or equal to y less than or equal to d. So some curves can be defined in terms of x, then the length will be the integral from c to d, the square root of 1 plus dx dy squared. Okay, but I'm going to give you another easy one. This one is almost the same problem. Nope, that's still that. I need something that's not so, that's easy, but not like ridiculously easy. They all are. Okay, give me 1 second. I'm going to check my reference because the ones I have are really simple. Okay. Here's one. So y, so again, find the length of the curve. If, and the curve is given to you as y is equal to 1/3 x squared plus 2 to the 3/2 power on the interval 0 less than x less than 4. So this is another easy one. Okay, so this one is pretty okay. All right, so let's do this one and then we're going to step it up a little bit. Okay, so I know why. So let's, so y is equal to 1/3 x squared plus 2 to the 3/2 power. So find dy, please. Then square it, please. And then compute the square root of 1 plus dy dx squared. So I'll give you a few minutes to do that. Okay, that's the one thing I like about these problems. They are straightforward. You just do that. They're straightforward. Everyone should be trying to figure this out. And I will stop and take attendance. Okay, so what's dy dx?
I got, did I get? I got x parentheses x squared plus 2.
Anybody else get something different?
I got that, but I raised it to the 1/2 power.
Oh,
half power.
I missed that.
Okay, so that's to the 1/2 power. Okay, any questions?
Yeah.
Yes.
What? No, man. I see what I did. No, man.
Okay. We all use the chain rule? Okay, so then dy dx squared, what do we get? Hello? Dy dx squared, what do we get? Should go for the jugular. What is the square root of 1 plus dy dx squared? Hello?
See, I think I got it wrong.
Okay,
Because I
it
got the
doesn't
first
matter.
one.
Let's keep going. I'll help you if you did. So what did you get?
I didn't even, I just thought that we was supposed to do the dy dx what the answer for dy dx is and plug it in. And that didn't turn out right.
That's not going to turn out right at all. No, that's not going to be pretty at all. But we can do dy dx squared. And what do you get?
Would it be x squared with
Okay.
parentheses, the x squared plus 2? No,
Okay.
3/2.
Okay, we're raising it. So when we square it, we're raising it to the second power. So the 2 and the 1/2 are going to divide out. So we're just going to get that.
Okay.
Okay. All right. Now what is 1 plus x? So now we're going to get 1 plus dy dx squared becomes 1 plus x to the 4th plus 2x squared. So this now becomes the square root of x to the 4th plus 2x squared plus 1. How in the world am I going to integrate that?
Take
You
out
use
the
power over
What'd you say,
I have
Victor?
a question.
Okay, what's your question? Okay, somebody had a question. Okay, so go ahead, Victor. What were you saying?
I'm saying to the value of x the value of x to the power of n plus 1 or over n plus 1, which would be it'll be 1/5, it'll be 1/5.
Oh, okay. I can't integrate that like it is because it's inside
okay.
the square root. Okay,
Oh,
I see. Yep, it's inside square root. Come on, guys, we running out of
Okay.
time. Come on, come on. Tell me, how am I going to integrate this thing? This is not a difficult problem.
Don't you have to take out the square root? Out that
Well,
part?
remember, we're going to integrate. The length is the integral of that thing. So we're going to go from 0 to 4 of the square root of that thing, which is x to the 4th plus 2x squared plus 1 dx. Now, how am I going to integrate that? That's what I'm asking you.
Use substitution.
Not quite. Easier than that.
Would you factor?
Factor it. Who said factor it?
Yeah.
Okay, that's what I'm going to do. So this is the integral from 0 to 4. When I factor this thing inside, this becomes x squared plus 1 squared. These problems are made to work out, guys. They're made to work out. They're not giving you the length of any old curve. They're giving you the length of a curve you can figure out. Okay, now what happens to the square root? When I take the square root of something positive, it's just that thing. One-third x cubed plus x. Evaluate between 0 and 4. So this becomes 4 cubed is 64 plus 4. Then I'm going to subtract 0. So that's 64 thirds plus 12 thirds. It's going to give me 76 thirds. Okay, any questions? Okay, let's go on to a little bit more difficult one. So here's my curve. Let's do x is equal to y cubed over 3 plus 1 over 4y and then y is between 1 and 3. Okay, so this curve is given to you in terms of X as not in terms of Y. So it is a function of Y. Okay, so that means we're going to have to use this formula. L is going to be the integral from C to D. C and D are given, so we already know that. We're going to get the square root of Y cubed. Oh, nope, what am I writing? The square root of 1 plus the derivative of X with respect to Y dy squared. Okay. All righty, so here's X. Y cubed over 3 plus 1 over 4 Y to the negative 1. Okay. You need to find dx dy. Then you need to find dx dy squared. Then you need to find what 1 plus dx dy squared is, because that is what's going to go in the square root. So you need to find those 3 things. Anybody need any help? Everybody know what we're doing? We know what we're doing.
Can you scroll up for a reference, please?
I certainly can.
Thank you.
Anybody want to give me dx dy first?
I got it.
Okay, what do you have?
Y squared minus 1 over 4y squared.
What's the power there?
2
How'd you get 2?
because no, would it be 3? I got 2 because when I did y over 3 plus 1 over 4 y minus 1.
Okay, and then you subtracted 1 from minus 1 and you got,
It shouldn't be 2.
it should
Then I
be,
subtracted 1 from minus 1.
it should be
-2.
negative 2.
Negative 2.
Okay, that was pretty good though. This is a tougher problem. So that was very good. Just made a
I
little
keep getting
mistake.
it wrong.
I know, it's frustrating, isn't it?
Yes, it is.
Okay, well, we're going to keep trying. We're going to keep working on it. Okay, now this next piece, I foil. You got to foil that thing. Okay, what did we get? This is why algebra is so important in calculus. Anybody get an answer?
I think I kind of got it.
Okay. Let's see, what did you get?
Would be y4 to the
Y
fourth
to the
power,
fourth power, good.
minus 2/4.
Minus 2/4.
Then the last one should be minus, it's like 1/4 y -4.
Okay. But I have 1/4 and 1/4.
1/16.
Good. Okay. All right. Can we make that look nicer? Can we multiply everything by 16? So we get 16y to the fourth minus 8 plus y to the -4 all over 16. Okay. Only have 1 more minute, so we're not going to finish. I'm going to add 1 to that. 16y to the fourth minus 8 plus y to the -4 over 16. And I want you to find a common denominator and simplify that and make it look like something that I can integrate. And we will pick up here tomorrow.